Great, you're back. So, a little more work with transformations and coordinate geometry unit as we work our way through the ears open for the mystery sound as we work our way through. So, as you can see from the screen, the topic is reflections. And I don't know how many of you have ever been to Washington, D.C. and seen this particular site here. It's called the Reflecting Pool. That's the Washington, Lincoln Memorial down that end. That's the World War II monument. And off in this area here is the Washington Monument. So it's called the Reflecting Pool because if you're looking at it from the other direction, what you will see in the pool is the reflection of the Washington Monument. There's a picture there. It's a kind of a cool place. I like Lincoln Memorial myself, but that's just me as we move forward. So reflections you've seen before, and the other thing that reflections are sometimes called, they're called flips. Oops, where's our little, there he is. Okay, so picture the monkey, we're just flipping ourselves, flipping around. So what that means in terms of the math, I'm going to try this out and hope it actually shows up as we do this, is I could take some sort of a shape, pop it onto the screen, and then I can say, hey, I want to reflect this about the x-axis, and you'll see what happens when I do the reflection about the x-axis. It flips, turns over, turns upside down. Or if I want to do it about the y-axis, it flips. Okay, so see how, if I can fold, you can't see me actually moving my hands, but if I could fold that paper right on the dotted line, the two images would line up, and whether I do it that way or whether I do it this way, if I fold the paper downward, I'd end up with the same thing. So the same shape sitting on top of each other, and I don't know, just for fun, we'll do the diagonal line. Ooh, there you go. That was kind of not really that great, but the idea that we're flipping things over an axis, over a line. Okay, hope that showed up. So here's a particular one that's all set up for us to do. As I get my pen out and working, which I now have, I forgot, too many hands. That's why I could try to fold the screen. But what we've done is we've taken this shape right here, and sticking with the boring old triangle ABC, and we've done a reflection. Really dark. We need some color. We've done a reflection over the y-axis. Okay, this is the y-axis right here. We've just taken the shape and we've reflected it over the y-axis. So you notice what happens is that point B is now there. And again, for the same notation, we call it B prime to indicate that we've done some sort of movement. Point A is over there as A primed, and point C is over here as C primed. So when we do that reflection, let's take a look at what happens to the coordinates before and after. So this point right here is at -2, 1. Its counterpart is at 2, 1. Back here, we're going to rough it in here. It's going to be about -4, 1. Its counterpart at +4, 1. And this guy here at -1, 2, 3, 4, 5, -5, 4. Its counterpart at 5, 4. Generally, you might see a pattern there as to what happens when we reflect over the y-axis. Okay, next screen, we're going to reflect over the x-axis. So reflect over, or you might read across, the x-axis. So when we do that, this is the x-axis. We've just taken the shape, flipped it down there, flipped it over, made it upside down. So again, notation-wise, this is point A, this is point A primed. If this is B, this is B primed. And if this is C, down here is C primed. Okay? We're going to approximate the points, go for a different color. This guy still is about -2, 1. Its counterpart is at -2, -1. Here we're at -4, 1. Counterpart, -4, -1. And lastly, point C is at about negative, what do we say, that's -5-ish and ish. -5, 4. Its counterpart is at -5, -4. So You might have noticed what happened as we did that particular reflection. Okay, I'm going to just change one little quick thing so that the next slide is perhaps the one that I want. I think. There it is. Okay. So as we move there, so we were here, we reflected over the x-axis. You saw what happened as we did that, what happened to the coordinates. So generally, let's look for some sort of a rule. Okay. When we did the reflection across the x-axis, so we had the shape up here and it reflected down there, what happened to my coordinates? Okay, did my x-coordinate change at all? No, right there, right there. My x-coordinate stayed exactly the same, and my y-coordinate, if it was positive 2, it turned into be negative 2. So xy turned out to be x, negative y. So now what happened? Okay, 4, 1 turned into negative 4, or negative 4, 1 turned into negative 4, negative 1. So the only thing that changed was my y-coordinate went from positive to negative. Okay, so that's the rule for that one. When I did the reflection across the y-axis, my triangle went like that, and then let's see if I can recreate that mess. Ish. I'll pretend. Something like that. So in this case, my y-coordinate stayed the same. The thing that changed was my x took on the opposite side. If we look back 2 slides ago, okay, my x went from negative 2 to positive 2, negative 4 to positive 4, negative 5 to positive 5. But the y-coordinate on all of these stayed to be exactly the same. Okay? So those are sort of the rules that we work with as we move through this coordinate geometry stuff. So rules are good. There you go. That's what we do when we make a rule, apparently. So we can reflect about other things beyond the x and the y-axis. I can just reflect about this particular line here, which is a vertical line, and this vertical line is x equals 2. Everywhere on this line, x is equal to 2. I can just take this and I can flip it over that line. Doesn't really matter. The line doesn't know where it is. Okay, I don't have a fancy device to do that, so we'll work it ourselves. Okay, what we need to look at is how far is, let's give these some names, A, B, and C. Okay, how far is point B from my line of reflection? It's 1, 2, 3. So to do the reflection, I go 1, 2, 3 the other way, and that's my new point B primed. Okay, this guy here is 1, 2, 3, 4, 5-ish from the line, so we go 1, 2, 3, 4, 5-ish from the line. Okay, and C is 1, 2. Let's see, what is it? Let's try it again. 1, 2, there it is. 3, 4, 5, 6 from the line. So we go 1, 2, 3, 4, 5, 6 from the line, just barely on the screen. So this one was A primed. That up there is C primed. And let's use the line tool to make it look nice. Okay, we reflect that point over that line. We get something that looks like that. So we can reflect over any line. We have a rule if we have rules for just over the x and the y-axis, but we have a brain to do it when it's about some other line. We could reflect if we wanted to about, if I put a line down here-ish, like that, we could do the reflection. It would just be a matter of, okay, this point B is 2 away, so the new point B would be 2 away. That'd be B. We'll call that prime still. This one's 2 away, so we go, oh, what did I just do? Strike that, reverse it. Okay, 2 away, 1, 2, so let's see if Mr. Tay can count. 1, 2, there you go. What is that? It's ridiculous. There you go. All right, so, and this one would be 1, 2 down, so it'd be like there, so it'd be B primed or something like that, A primed. So, that's how that works, okay? So the thing that we've been keeping track of as we go is what changes when we do a reflection, or any transformation, but today it's reflection, and what stays the same. So as we look, let's start with what stays the same. My sides, the length of my sides change when I do a reflection? No. Okay, so my lengths stay the same. Okay, if it was 2 inches before, it's 2 inches afterwards. Okay, so my lengths stay the same. Do my angles stay the same when I do a reflection? In other words, is this angle right here the same as that angle right there? If I had a right triangle before I flipped it, is it going to be a right triangle afterwards? Yes, indeed. So my angles stay the same. My coordinates, clearly those change. Coordinates, there you go. That is perhaps the worst spelling of coordinates ever seen before. Making it worse. And what about the slopes? Do the slopes of my lines change? Okay, the slope of this line didn't change. AB stayed the same, but clearly this one's got a negative slope. That one's got a positive slope. So the slopes can change. So we're going to say that the slopes are something that will change as we do a reflection. Okay? So we're keeping track of what happens, you know, and if we do a reflection, if you're doing an animation, obviously when you look in the mirror, you shouldn't see yourself unless you're at a fun house or something. But when we do any kind of reflection, we want things to sort of stay the same, but you see that opposite, that, well, the mirror image is sort of what happens, right? I don't know what I'm drawing. Maybe it's a mirror. I'm not going to try to, all right, I am going to try to draw a picture in there. All right, so I've rambled on for 11 or 12 minutes now with only one thing in mind. So I think it's time to say goodbye, and we hope everything is all fine with you. Oh, I don't know what that noise was, but that wasn't the mystery noise. Or was it? Hey, thanks for watching. I hope you learned something, and we'll talk to you soon.